that for this?
Yes.
Yeah.
80 miles south of the Arctic Ocean, on a desolate stretch of Alaska's Dalton Highway, Team Viper prepares their equipment. Viper stands for Vegetation Impacts on Permafrost. Just beneath the surface lies a layer of solid frozen ice and soil. This is permafrost, and it's been frozen for about 200,000 years. But the warming climate is causing it to thaw, and the team is trying to understand how the surrounding vegetation might influence the rate of thaw.
And we need that too.
The team is traveling to 24 research sites in Alaska, and each site has a different ecosystem, different plants, types of soil. Some sites are in the mountains and have trees, while others are on the open tundra. Some have lots of standing water and tufts of grass called tussocks, while others are soft, mossy, and dry. Team Viper is studying how the different ecosystems influence the temperature and depth of the underlying layer of frozen ground.
My name's Mike Loranty. I'm an assistant professor in the geography department at Colgate University. And we're in the Arctic tundra, so you can see forever.
Today's site is called Happy Valley, and white puffs of cotton grass and bright yellow Arctic poppies cover the ground. It's chilly and windy, but the tundra is almost always windy, which is okay because it keeps the mosquitoes down. The ground that thaws and freezes each year is called the active layer, and they cut out small chunks of soil to sample. In some places, sometimes only 6 inches beneath the surface, suddenly you can't dig any further and your shovel scrapes against the solid layer of permafrost. At the surface, Loranty crouches over a plot of ground, clipping grasses, shrubs, and moss. He's trying to get an idea of the variety of vegetation this ecosystem supports. Looking at the vegetation, soil, and permafrost is like taking an inventory of this ecosystem, and this site is part of one big project. Loranty and colleagues from the University of Alaska Fairbanks and Woods Hole Research Center are looking at sites all through Alaska and in Siberia to get a snapshot of how ecosystems and permafrost interact throughout the Arctic. And because the climate is warming, this interaction is not static. The permafrost is warming up, and the vegetation above it is changing.
It's pretty cut and dry. There's evidence all over the place. I mean, you can look at ice cores, you can look at kind of sediment records, you can look at all sorts of different records that we have, climate records going back a long, long time, records in tree rings. You know, they all show the same thing, and there are a lot of big things that are irreversible, right? Permafrost thaw is irreversible. Ice loss is irreversible.
And losing the permafrost matters. The Arctic is cold, so it takes a long time for organic matter to decompose, and so it's trapped in the permafrost. As the permafrost warms up and thaws, that organic matter can now decompose, and this adds carbon dioxide to the atmosphere. This is carbon that's essentially been removed from the global carbon cycle for tens of thousands of years. Loranty likens this to fossil fuels that geologically have been in storage for millions of years and took millions of years to accumulate. But now we're removing that store.
And we've very quickly taken it out and put it back into the atmosphere, which is causing the climate to change rapidly. So permafrost carbon is quite similar in that it's been taken out of play from the global carbon cycle, and we're poised to very quickly put it back in. You know, we've had a series of assessment reports over the past 2.5 decades, and if you look back 1990 and see what we projected for 2000 or 2010, we're overshooting everything. It's kind of disturbing to think about.
This is a special landscape. It's not like anywhere else. In the middle of this vast expanse, you feel incredibly small and insignificant. To the naked eye, it looks empty, and it's almost too easy to overlook the complexity and fragility of this ecosystem, whose secrets of the past and the future are locked in the ice below.